Hi everyone, I am Meghna Madhusudan from the NFS-Ganesha team. Today this session is about the highly available active-active NFS server on GlusterFS storage system. So let me explain the agenda of today's session. First, I'd introduce you to what NFS-Ganesha is and what the integration of NFS-Ganesha and GlusterFS really means. And then I move on to the high availability of the NFS-Ganesha servers that we have implemented. And then I also introduce you to the new Gluster CLI that has been introduced to make the configuration of Ganesha exports easier. And then I move on to what active-active NFS-Ganesha really means, what are the challenges involved, and some of the new framework functions that we have introduced. I'm going to talk about that. Then finally, I'd end this session with a quick demo of a failover scenario where I kill NFS-Ganesha server on one of the nodes, and then we'll see how it fails over from one node to another without the I/O getting interrupted. So what is NFS-Ganesha? NFS-Ganesha is a user mode file server, and it supports NFS v3, 4.0, 4.1, PNFS, and 9p. It's an open source project where it provides a Fuse compatible file system abstraction layer that we call as FSAL to plug into any storage mechanism. The upstream NFS-Ganesha community today supports file systems such as Lustre, GPFS, XFS, and GlusterFS as well. And we have integrated it with GlusterFS using the libgf API library, which is available via the GlusterFS API and GlusterFS API devel packages. And NFS-Ganesha also uses something called as the debus mechanism. So if we have to export or unexport any Gluster volume via NFS-Ganesha without having to restart the server, we use something called as debus signals, which can be sent to the server, which it picks up and adds an export or unexports the volume without restarting the NFS server. So now I move on to the important topic of today, that is high availability of NFS-Ganesha server. So we have implemented an active-active solution, and it is achieved using pacemaker and corosync. And we need some input from the user. So what are the inputs? So we need the servers, that is IP or hostname of the servers that you want to be added to the cluster along with the virtual IPs. So that means to say, let's say you want to add 4 nodes, that is RHS 1, 2, 3, and 4 to the Ganesha HA cluster. You have to have a VIP assigned to each of these nodes, and you have to provide this pair of server and VIP for making the solution work. And these input parameters are taken via a configuration file called as ganesha-ha.conf file. And what the script internally does is it sets up the entire cluster for you. The entire HA cluster is set up, and also the script can be used to tear down the cluster as well. It's important to note here that not all the cluster nodes are necessarily a part of the Ganesha HA cluster. So whatever servers you give as an input in the HA conf file, only those nodes will be considered when you set up or tear down the entire cluster. And new resource agent scripts have been added to monitor the NFS service on each node. So there is a heartbeat going on in the HA cluster that we have already created. Pacemaker used to do that. So whenever a node goes down in the cluster, each of the other nodes is notified that one of the nodes, the server on one of the nodes has gone down, and let's take appropriate action. So we have introduced a few research agents with the name Ganesha-Mon, Ganesha-Grace to take care of such functionalities. And then let's consider a case where NFS service has gone down on one of the nodes. So the entire cluster is put into Grace. So this is important because data consistency has to be maintained when there are multiple servers servicing multiple clients. So the client the client that is connected to server 1 will now be redirected to server 2. So by the time this movement happens, no other IOs will be allowed, because this client has to still recover its locks, and only then will the other IOs will be allowed to proceed. So we induce a grace period in all the servers in the entire cluster. Again, we use the debus mechanism here. So we send a debus signal to each of the nodes with the node ID of the server that has gone down. So let's say the server on node 1 has gone down. So we send a debus signal to node 2, node 3, node 4, say with node 1 in the signal saying the server on node 1 has gone down. And the whole implementation is quite complex, and it will be difficult for the user to perform all the steps by himself. So we have integrated this with the Gluster CLI to configure NFS-Ganesha. That means to say we help them, the CLI would help to set up the HA cluster and also exporting and exporting individual volumes. So what are the required packages that would be required? So you would need Gluster RPMs greater than 3.7. You need GlusterFS server RPMs, API and API Devil, and also the GlusterFS Ganesha RPMs. This is a new sub-package that has been introduced. So this has all the resource agents that will be required, and also the example config files and the scripts that you would require to set up HA. All of these are bundled in this new sub-package GlusterFS Ganesha. And then you would need the latest Ganesha RPMs. So the first one is NFS-Ganesha. The second one is the FSAL specific RPM. So you need NFS-Ganesha FSAL cluster to be installed on your system. And it's very important that you follow these prerequisites that I'm going to explain now in the specific order. And even if you miss one of the steps, the HA cluster won't be set up successfully. So it's very important that this order is followed, and all these commands are executed on all the nodes that you want to be in the Ganesha HA cluster. So first, populate the ETC hosts on all machines. So each of these hosts have to be identified by each other. So all the nodes should be populated with the details of all the other nodes that you have in the Ganesha HA cluster. The second one is disable and stop network manager service, enable and start network service on all machines. The third one is the most important step. We need a shared volume to store some NFS state. So this NFS state has to be shared by all the nodes. So what you need is to create a cluster volume with a specific name called cluster shared storage, and you mount it on var run cluster shared storage. Again, this path is also fixed on all cluster nodes using GlusterFS native mount only. Make sure that you use the correct volume name and the correct mount path, because it's a common meta volume that will be used by other features of GlusterFS as well. So it's mandatory that you use this specific volume name and the specific mount path. I'll explain the significance of this shared volume in a little more detail going further. The next one is create a empty file called etc.ganesha.conf. Right now it's an empty file, but we might need some global parameters a little later for lock recovery. So that will be added a little later. And for now, you can just touch an empty file called etc.ganesha.conf. Then you will need resource agents that I've talked about, pacemaker and corosync. So install all these resource agents, pacemaker, CMAN, PCS, CCS, resource agents, and corosync on all the machines that you intend to run Ganesha on. And the sixth one is you have to have a user called HA cluster on all of these machines, and make sure that you have the same password for this user on all the machines. And run PCS cluster auth on all the nodes. So let's say you have node 1, node 3, node 4 in your ganesha-ha.conf that I talked about. So you have to run a PCS cluster auth NFS2, NFS3, and NFS4 on node 1. And on node 2, you'd have to run NFS1, NFS3, and NFS4. something like that. So this is what you'd have to run on each of the nodes. Then enable IPv6 on all the nodes. So you'd have to edit a file called etc modprobe and IPv6.conf. So you have to edit that file and reboot your system if an IPv6 is not enabled. And then start PCST on all the machines. And the most important part is edit this file called ganesha-ha.conf if it's not already present. If it's not present, create a new file by looking at the sample configuration file. So let me show how the sample configuration file actually looks like. So you can see that the first parameter here is the HA name. So what it means is the name of the HA cluster that you'd want to create. So this should be unique in the entire subnet. You shouldn't have another cluster with the same name in the subnet, then it will otherwise it will fail. So make sure you have a unique name here. And the second one is the HA vault server. I already talked about a shared volume that you'd have to use and mount it on each of the nodes. So you will have identified a server from which you would have mounted it. So what server have you used? We need to know that. Write that server against the HA vault server parameter, and then the list of the nodes that you want to run Ganesha on. So these nodes will be the part of the HA cluster Ganesha-HA.360 that you've given on top. So let's say if given server 1 and server 2, only these two nodes will be part of the cluster. Even though you have server 1, server 2, server 3, server 4 in your cluster trusted pool, only these two servers that's part of this list will be considered to create the cluster. And then you'll have to have a VIP against each of the server, each of the servers that you've given in the list. So you have to give it as VIP underscore name of the server is equal to and the name of the VIP that is assigned to the server. So a new CLI that we have introduced in 3.7 would enable the entire cluster and takes all the steps that's required to enable or disable the cluster. So the first command is a global command called GlusterFeatures.Ganesha enable or disable. What does GlusterFeatures.Ganesha enable do? So it disables Gluster NFS across the Gluster trusted pool. So you cannot have two NFS servers running on the same node, and neither do you want to end up in a situation where you have a set of nodes in the Gluster trusted pool running Gluster NFS, another set running Ganesha. So to avoid such situations, even before you go ahead and attempt to start Ganesha, you'll be prompted whether you want to disable Gluster NFS or not. Only if you say yes, will you go ahead with the next steps. So the Gluster NFS server is disabled across the whole Gluster trusted pool. And the second step is it starts the NFS-Ganesha service on only the nodes that you specified in the Ganesha-HA.conf, the list that I showed you, right? Only on those nodes will Ganesha be started. And the third one is it sets up the NFS-Ganesha cluster. That means to say it creates the necessary resources and the heartbeat is set. So anything, if any node, if any server, any of the nodes goes down, you would know. So the cluster is up and running and the Ganesha service is also up and running. But this option will not export any cluster volume by default. So if you have to export any volume, you would have to run the following command explicitly: cluster vol set vol name Ganesha enable on or off. So when you do an enable on, what it does is it creates an export file with default parameters that is read by Ganesha, and then it sends a debug signal to the service, to the Ganesha service, saying dynamically export this volume. A unique export ID would be given to each of these exports, and this debug signal will make it exported via NFS-Ganesha. And what does GlusterFeatures.Ganesha disable do? So this is also a global option. So what it does is it stops the NFS-Ganesha service on all the nodes that you had specified in the previous file, and it tears down the entire NFS-Ganesha cluster. So it stops the service as well. All the resource agents are stopped, the resources created are destroyed, and also the Ganesha service won't be running on any of the nodes. But it does not bring GlusterNFS up. So if you have to get GlusterNFS back, you'd have to run the gluster set command again to get it back again. So this so consider a case where you want to add a new node to the existing cluster. So let's go back to the config file. So consider a case where you had specified server 1, server 2, and server 3 in your cluster node list, but you want to add a new node. For those cases, the script which I had already talked about, the Ganesha-ha.sh script, so it has two options called add node and delete node. So after cluster peer probe, or if the node is already part of the cluster trusted pool, you'd have to run this script explicitly to add or delete node so that your HA cluster gets modified. Sorry. Now I move on to see what active-active NFS-Ganesha really means. So a case where each of the servers is up and running, it's already servicing another client, and if any of the servers goes down on one of the nodes, this server, the client connected to this server, will be redirected to another server that is already active and is already servicing other clients. So that's what active-active NFS-Ganesha means. And it's also possible here in this case that there is simultaneous access via multi-head NFS-Ganesha server. So that means to say, consider a volume called test wall in the cluster trusted pool, and you have 3 NFS-Ganesha servers running. So you can have 2 Ganesha servers servicing 2 different clients, but the same volume and the same file. So there will be cases where there's simultaneous access on the same file by 2 different Ganesha heads. But there is a challenge involved here to maintain data consistency. So what is the challenge here? So let's consider a case where client 1 is connected to server 1 and client 2 is connected to server 2. So each of these clients have a cache of their own. So there could be a possibility where there will be a possibility where the client 2 has written some data into file 1, and the file 1 has changed, but the client 1 here will still be reading from its cache where the changes have not been reflected yet. So it does not know that it's the cache that's holding is stale and it's reading inconsistent data. So to avoid such situations where 2 clients are reading 2 different content of the same file, we need something called as the upcall infrastructure. So what happens today is in the cluster case, so the client sends an RPC request and the server responds with the reply. There was no infrastructure where the server could initiate a callback to the client by itself. So this is required here in this case, because whenever there is a change in a file, so the server has to notify the client saying, client, you're reading old data, your cache is no longer valid, invalidate your cache. So this is what the upcall infrastructure brings to the table. So it's a generic and extensible framework, and it's used to maintain states in the GlusterFS process for each of the files accessed. So whenever there is any change in that state, it just sends a notification to the client saying invalidate your cache, and from the next access, it again populates its new cache, and this is called as cache invalidation. So this is one of the features provided by the upcall infrastructure. So this upcall is generic, so you can send a call back to the client, and there could be many use cases to this, but one of the major use cases that we are using today is cache invalidation. So we have introduced two volume set options here called cluster vol set features.cache invalidation on or off. It's an accelerator option. And you can also set the cache invalidation timeout. So what it really means is, so the default cache invalidation timeout is 60 seconds. So only if the access has been done in the last 60 seconds will the invalidation signal make sense. If it is after 60 seconds, the client would have invalidated its cache anyways. So you can also configure your timeout to be more safer. If you want, you can decrease the timeout to make sure that it just wouldn't read any stale data. Even within 60 seconds, you can reduce it to 45 seconds as well. So this is what this option provides you. It allows you to configure the features.cache invalidation timeout value. So this is a pictorial representation of the demo that I'm going to explain. So the the square boxes here, those are the nodes, and the darker vowels here that you can see are the Ganesha nodes on each of these nodes. So Ganesha server is running on each of the nodes, and a VIP has been assigned that you can see there in green. VIP, VIP 2, 3, and 4. Each of the Ganesha servers has a virtual IP associated with it. And let's say the client 1 is connected to client server 1, and all of these are bundled together, or all of these are part of the Ganesha HA cluster, and all of these are connected to the shared volume storage. So I was talking about the shared volume storage here. So what happens is whenever a server grants delegations or locks, so it will maintain some state saying, I have given this lock to this client. A delegation has been granted to this client. So this information is stored because whenever there is a reboot of the server or the client, so we require the client would replay its locks. So it's important that the server has this state within itself, so that the client can recover its old locks. So it's required that the server has this information. The same need can be extended to a failover case as well. So let's consider the client 1 was talking to server 1, and the server has granted some locks, and server 1 goes down and the client 1 is redirected to server 2. So the server 2 now has to know what the locks that were granted to client 1 by server 1 as well, for the correct behavior or data consistency and correct lock recovery. Server 2 has to know what was the lock state of client 1. So this has to be stored in one volume or storage that can be shared by all the nodes. So we create this shared volume, that is Gluster shared storage. So this volume is very, very important for you to maintain data consistency and lock recovery. So as you can see that all of these have this shared volume mounted on their nodes. So it is depicted here that the client 1, which was connected to server 1, after it goes down, it is just directly reconnected to VIP 2. So I'll explain. Before the demo, these are the references that you can use for the feature page. These are the feature pages that you can use to see what a little more details. So let me move on to the demo now. So I have a 4-node setup here. Let's check if PCSD is running. PCSD is running. And if you see the status here, you will see that no cluster is running. And let's check if Ganesha is running. Ganesha is also not running. Let me check if the shared volume is mounted. As you can see that cluster storage volume is mounted at var run cluster shared storage on each of these nodes. And we need a directory called NFS-Ganesha on this mount point. Let me check if I already have it. Var run cluster shared storage. You can see that NFS-Ganesha is present. So let me check the Ganesha conf. If it's empty, yes. And let me check if Ganesha-ha.conf, the sample configuration that I showed that time, is present on each of the nodes. You can see that each of the nodes have the same config file, and my cluster nodes are RHS1, RHS2, RHS3, RHS4, and I've mounted the shared volume using the server RHS1. So let me run the command gluster features .ganesha enable. This will set up the cluster, disable cluster NFS, and also bring up Ganesha server, the Ganesha service. As it requires a lot of steps to be done in the background, this command will take some time to finish. Meanwhile, I can show you where the Ganesha HA script is present. So if it's a source install, if it's a source install, you can find that script in user local libexec ganesha-.sh. Yeah, this is what takes care of creation of the resources and add node, delete node, everything. This is a script that takes care of that. And you also have the resource agents created and installed in user lib64 resource.d. Yeah, let me come back to that later. So let me check if the cluster is set up. So let's check using PCS status. Yes, you can see that these many resources have been created, and like you can see, the cluster IP resource of RHS1 is started on RHS1, RHS2 and 2 is on 2, 3 is on 3, 4 is on 4. So let me show it on all the group in the entire PCS status. Yeah, you can see this. So, but how does the failover really happen? How does node 1 know to failover to node 2 or node 3? So, depending on the scores that we assign. So, we have an algorithm today where we increment the scores in 1000. So RHS1, it depends on how you order your nodes in the ganesha.ha.conf. So RHS1 will have the highest score in the config file, and let's say RHS1 has the highest has a score of 4000. RHS4, let's say it has 3000. The next highest score will be RHS4. So RHS1 will fail over to RHS4. So whichever node is local will have the highest score, and the others will have the difference of 1000, 2000, and 3000. So whichever is the next highest score the server will move on to the VIP of that will be moved to the VIP of the node with the second highest score. So let me check if service NFS-Ganesha has started by doing a service NFS-Ganesha status. You can see that Ganesha is running, and let's do a show mount to see. So it has not exported in any volume by default. So now let me run the volume level command that will export my volume. So that is vol set. So now we can see that test vol is exported via Ganesha. So let's check if it's exported everywhere. Yes, as you can see that each of the Ganesha server on these nodes have exported test vol. So this is my client. So let me use it's important that you use the virtual IP to mount the volume. Only then will failover work. So if you use a physical IP, you can't see any difference. The IO will still remain like that, client will hang. So you have to use a virtual IP. So what is the virtual IP given to each of the nodes? Let me just check in the configuration file. Okay, so the virtual IP of RHS1 is this. So let me mount test vol using mount MST NFS. Before that, let me create mount 1 and mount 2. Okay, it's already there. So mount MST NFS test vol on mount 1. So the second node is 174. So I'm using a different Ganesha head to mount this now. So this is the second volume. So I'm going to mount that on mount 2. Okay. So both of them are mounted here. You can see that in version 4. And you can see in Gluster volume info that the feature cache invalidation is put to off. So I've put this to off to show you the use case of upcall infrastructure. So right now the upcalls are not in play. So we can see how without it, there will be a data discrepancy. So I'm going gate. Okay, so this is the first mount point. So now let me put a file called test file, and let me test file. And sorry. Okay, so I'll cd into mount 2 now. This was done on mount 1, so I'm testing. Let me see what test file says in. It says hello, but let me write something else into. Okay, and hello world, what does this say? Cat test file. See, it still says hello because it's still reading from the cache. So we have a data discrepancy here. If the client does not get a notification from the server saying your cache is not valid anymore, we end up reading wrong data. So let me enable cache invalidation now. Okay, it's enabled. Okay, now let's do the same experiment here again. Yes, so both the contents are same. So it has got a notification from the server saying invalidate your cache. After invalidation, you can see that the contents of uh, the same file on two different mount points that uses two different Ganesha heads are the same. So this is a use case of the upcall infrastructure. So let me unmount. So you can see that there's a file called file1. So let me just remove that and yeah, and out a new file. I'm going to demonstrate a failover scenario now. So HA test. So this is what the test is doing. So as you can see here, so I'm writing hello world 50 times into this file called file1 on mount 1 and on the mount point mount 1. So what I'm going to do here is I'm going to start this test and kill the NFS server on RHS1. That's where if you can see, I have mounted. Uh, mount 1, the Ganesha head is corresponding to RHS1. So I'm going to kill Ganesha on RHS1 and we'll see how we can, how IO does not get interrupted because of that. Okay, let me start the test. And you can I've started the test now. You can see it's written 7 times. So I'm going to, yeah, service NFS-Ganesha. I'm going to kill Ganesha on RHS1. So you see Ganesha. So Ganesha service is not there. Status. Yeah, Ganesha NFS is stopped. So let me check the PCS status now. You can see here very clearly that the cluster IP has been moved to RHS4. Previously, it was started at RHS1. Now you can see that the virtual IP has moved to RHS4. So if you do a if config, sorry. So let's check. So you can see that it's still running and yeah, so I can just show here in RHS4. You can see that the virtual IP of 1070.40.173, which was the virtual IP assigned to RHS1, has been moved to RHS 4 here. And you can also do a test like this. So localhost wouldn't give you anything, but the virtual IP here would still be serving your volume 70, 40, 170. That's the virtual IP of the same host. You can see the test wall is there. Yes, you can. If I do cat on file 1, you can see it has successfully written till 50. Failover has happened successfully. So this is all it was about highly available active NFS-Ganesha server. If you have any questions or queries that you would want to reach out to us, write us at GlusterDevil or at NFS-Ganesha. We'd be happy to help. So it's me, Meghna, signing off now. Thank you, everyone.